All right, this is part 2 of the total internal reflection video. Okay, so it's basically a combination of refraction and total internal reflection. Okay, draw a diagram for the following, blah, blah. Okay, so we're going from air to glass. So if we're going from less dense to more dense, the bending will be towards the normal. We're going from water, so let's just say water is up here, into air. You're going to bend, instead of continuing straight, you're going to bend away from the normal. You always measure your angle with respect to the normal. Number 15, a light beam hits a sheet of glass at an angle of 25. And what angle will it be refracted? Now let me just take a look here, because I don't know what I use for the index of refraction for glass. So I use 1.52. Okay. Okay. So we're going to do Ni sine theta I equals Nr sine theta R. So I'm not going to write this every single time, but you have to write it when you're doing the homework. Okay, so we're going from air at an angle of 25, and we're going to get into glass. Now, make sure you are in radian mode, and you can solve that equation easily, and you should get about 16 degrees. Number 16. Now you're going from air to water, so you should get an angle that's less than 35. You got to bend in. So 1 sine of 35, water is 1.33 sine of the angle of refraction. Okay, so that should be about 25, 26 degrees. Okay, let's look at 17. A block of an unknown material is in a pool of water. Light passes through the water. That passes through the water is incident on the block at an angle of 27 degrees. So we're going from water to glass. Okay, so going from water at an angle of 27 into glass. I'm sorry, into this new material. We don't know what it is, right? Yeah, n sine of 20 degrees. And you can solve that equation, and you should get an n equals to 1.77. 18, they're giving you the speed of light in some plastic. What's the index of refraction? N equals c over v, so that's 3 times 10 to the 8 over 2 10 to the 8. So that should be 1.5. No units. Calculate the critical angle for water. So now, basically, in order to do that, you're going from water to air. You cannot go from air to water and try to find the critical angle. It has to be from more dense to less dense. So here's water down here. Here's air. Okay. So if you come in at the critical angle, there's no bending. Okay. So basically this means 1.33 sine of theta critical equals 1 for air sine of 90, because your angle of refraction is 90 degrees. And this should be about 48, 49 degrees. Like in the answer here I said 48.75, so I guess we'll go with 49. Okay. Number 20, you're going from air to glass. We're trying to find the angle of refraction, so we do 1 sine of 30 equals 1.52 sine of theta r. See how simple this stuff is? All right, let me just make sure I'm still recording. Yep, we're still good. Okay. Number 21, a light ray passing through air hits water. So going from air to water at an angle of 30. What is the angle of refraction? So 1 sine of 30 equals 1.33 sine of theta r. So theta r equals, best one I have here is 22 degrees. Okay. Yeah. Okay. What's the speed of light right through this water? So N equals C over V. Okay. Equals. Yeah. So basically, N for water is 1.33. This is 3e to the 8 divided by V. And you can just solve that equation to find the V, which is 1.24 times 10 to the 8. Okay. Number 22. What's the speed of light in diamond? So N equals C over V. So 2.42 equals 3 times 10 to the 8 over V. And the V for diamond is well, actually, the previous one, I'm sorry, it was 2.26 times 10 to the 8. This one is 1.24 times 10 to the 8. Okay, let's look at number 23. A light ray passing through water into polyethylene, N equals 1.50. The angle of incidence is 57.5. What's the angle of refraction? Easy. So you're going from water at an angle of 57.5. You're going into, I guess that's some kind of glass, sine of theta r. So theta r is equal to 48.40 degrees. Okay. What is the speed of light through the polyethylene? Okay. So N is C over V. This is 1.5. The C is the constant over V. So V should be, I think, 2 times 10 to the 8. Okay. All right, number 24. Calculate the speed of light in Lucite. So N equals C over V. There is a chart of the for the index of refractions in some of the previous pages, 3 or 4 pages back. And the N for that is 1.51. The C is a constant. And you can find the V. So it should be about 2 times 10 to the 8. It's actually 1.99 times 10 to the 8. All right. Okay. Okay, so for number 25, I think we have to use N equals C over V to find the speed first, and then do V is distance over time to find the time. So for quartz, the N is 1.46. So 1.46 equals 3 times 10 to the 8 over the V. We should get a V equal to, okay, I didn't calculate the V, but we can do that quickly. 3 divided by 1.46. So this is going to be 2.05 times 10 to the 8. You bring that here, equals distance, which is 1 meter, divided by the time. So if I just so the time would be 4.87 10 to the negative 9. So it's basically 4.87 nanoseconds. Critical angle for a medium is 40.5. What's the index of refraction of this medium? Now that's with respect to air, basically. So I think we can do sine theta critical equals 1, since it's air, over the index of refraction of that other material. Okay, so we can do sine 40.5 equals 1 over n. So n is going to be 1 divided by sine of 40.5, and should be about 1.54. So this n is 1.54. Again, no units. Okay. 27. The critical angle for a substance in air is measured at 53.7. So basically going from this substance into air, because you have to go from something that's more dense to less dense. If light enters this substance from air at 45 with the normal, at what angle will it come? Will continue to travel. So I think we have to find out what the n is first. So sine of this critical angle equals, since we're going into air, is 1 over n. So I think we can do this angle here is 53.7. So n is going to be equal to 1 divided by sine of 53.7. So it should be 1.24. Now you work the other way. Now you're going from air. We can going from you're going from air into the other substance. So it's going to be 1 sine 45 equals 1.24 sine of the angle of refraction. And that angle of refraction should be 34.77 degrees. So the answer is A. Okay, let's look at 28. Okay. A light beam is traveling inside a glass block that has an index of refraction 1.46. As light arrives at the surface of the block, it makes an angle of 35 with the normal. So that's your angle of incidence. Okay, so let's try to figure out what's the angle of, with what angle is it going to leave the block? Okay, so we're going to do 1 sine of 53 equals 1.46 sine of this critical angle. I mean, not critical angle, this angle of refraction. And if you do the math here, you're going to get an error. Okay, hold on a second. No. We're going from this substance. Yeah, we're going from this substance into air. Sorry. 1 sine theta r. If you do the math here, you're going to find out that this quantity here is greater than 1, and you divide it by 1. It's still greater than 1. Sine cannot be greater than 1. So you're going to have total internal reflection. The other way you could have done this is find the critical angle, and then you're going to see that the critical angle is definitely less than 53. So that's going to be, the critical angle is going to be like this. Sine of theta c equals 1 over 1.46. So if we find that angle, it's 43 degrees. So anything past 43 will not come out. Now for these drawings here, you just have to follow the answer key on Haiku. So basically what's going to happen here is you're going to bend twice. So you're going from air to glass. You can use, I think I use 1.5 for glass. I use 1.52. So you're definitely going to bend in, right? And then since these two lines are parallel, you probably can see that you're going to bend out the same angle you had here. So they're going to be parallel. So here you would do 1 sine of 60 equals 1.52 sine of theta r. This is the theta r. Okay, you can find that angle. Okay, now you come to this surface here. This becomes your new angle of incidence, which is basically the same as this. These two are equal because they are, what do you call that? Alternate interior, right? And then you would do the same thing here. So you would do 1.52 sine of this angle, which is the same as that angle, equals whatever that angle you're going to find, equals, now you're going into air, 1 sine of theta, another refraction. So I'll just put it as an uppercase R. And that's it. Yep, I think I covered it all. All right.